Hi, this is Paul again, and I've got another video to show you, and I'm calling this video Quad Step PHYLLOTAXIS 3D Order Lesson 3. Now in Lesson 2 I showed this dodeca that I show in front could fit perfectly into ring arrays of 48 balls and in 4 colors. Now these 48 ball arrays works around the vertices. Now I showed in my earlier videos on Platonic order there are 20 vertices and 20 vectors from the center of the dodeca. So the dodeca acts like a 3D processor. Now if we take a look at the face of the dodeca, we can also make an array around the face of the dodeca. Now this array works around the vector of the icosa, and the icosa provides 12 vectors. I'm not showing the icosa at the moment, but you can see that this fits perfectly into a 40 ball array, and this gives us 10 segments, very much like an orange. Now we'll go back to the 48 ball array. Now I'm going to just show you the dodeca outlines and just 2 Yucatan rings, because I'm just going to show you a cube in the dodeca outlines. Now I'm just showing the array of 2 rings, which is just for 1 cube. Now the dodeca contains 5 nested cubes, that's why we get so many rings. Okay, now I'm going to hide the white segments. Now you can see the red cube sitting perfectly, but we need a second cube around this vertical vector, and this new cube will be a yellow cube, and it will be perfectly golden ratio to the red one. If you look at the front pentagon, you can see these edges perfectly. Now you can see all this wonderful geometry is based around the vertical axis vector. Now look what happens when I rotate it at 7.5 degree steps. You can see that the vertices of the 2 cubes and the dodeca keep lining up with the 48 ball array. Now I've showed in my earlier videos that the red and yellow cube, which are golden ratio to each other, can be the basics for the geometry of AD and A. Okay, I'm going to show this animation in the top view as well. I think it's very interesting, because the polar array of 4 colored cubes that I am showing seems to expand the geometry, because I showed in earlier videos that this geometry was giving us 3-phase sine waves and sound waves, because I think this system can keep doubling up just like harmonics. I think it's time that the scholars start looking at these discoveries of mine, because this is 3D reality, this is not a theory. Because this quad step PHYLLOTAXIS has given us 3D geometry for the pineapple, strawberry and a pine cone. And this has never been achieved with the chaos theory. Okay, now I've showed you 48 ball 12 section around the vertex of the dodeca. So now I'm going to move the axis from the vertical to the center of the pentagon of the dodeca. Now this center axis is basically the vectors of the icosa, but I'm not showing the icosa. So now I'm going to give it 10 copies around this axis. And you can see in the geometry there are 12 of these faces. So this 10 segment array can be produced in a nest of 6 axes. And the 12 segment array can be produced in a nest of 10 axes. So now I'm going to hide the white segments. And now I'm going to rotate this geometrical assembly every 9 degrees, and it lines up with the balls each time. Now these balls could be doubled up to 80 or 160. So what we're really getting is positive growth, unlike the fractals, which are negative growth. Okay, now I'm going to focus on the yellow cube. And now I'm showing an axis from the top and bottom face of that cube. First I'm going to rotate the face around a little bit. And now I'm going to give it an array of 8 segments, which will be a 32 ball array. Now watch these segments going around. They are lining up not only with the vertices of the cube, but also the vertices of the dodeca. And it's also lining up with some of the midpoints of the edges of the dodeca. And now I've got something else to show you. Now if you look at the faces of the cube, I show little blue vertices. Now these are the vertices of the octahedron. Look what happens when I scale it up to them little green balls. Now these 2 green balls form the diameter of the spherical profile of the dodeca. Now these diameters are basically vectors. Now we have 5 cubes, so we have 5 octahedrons also. Now these vectors pass through the midpoint of the edges of the dodeca. And we have 30 edges on the dodeca, so that makes 30 more vectors. And these 30 vectors are responsible for the 4-fold geometry that I am showing. I'll add 3 rings of the vertices of the cube and the octahedron. And now I'm going to add a profile curve with 3 sets of 4 colored balls. And now we can give this also an 8-segment array of 32 balls. So you can see the vectors between the vertices of the dodeca and the icosa and the octahedron are the basic vectors for a 3D processor. And this processor of the dodecasphere gives an integrated system of 4-fold, 5-fold and 6-fold, and I'm showing this in reality. Okay, I'm going to keep this same 32 ball array and bring in the tetrahedron. And now we'll give it 8 segment copies again. And you can see that the 32 ball array and 8 segments line up to the vertices of this tetrahedron. So this polar array should go around the 6 faces of the cube. So let's focus on that tetrahedron for a minute. And for this we'll hide the white curves. Now look what happens when we rotate a copy of that tetrahedron 90 degrees around the same axis. Now we have produced the Star of David. So it's obvious that these incredible systems of order are produced around the vectors. Now I've showed that the cube and the tetrahedron and the octahedron are all the same spherical size as the dodeca. Now the icosahedron seems to be the only spherical size that is different. So now I'm going to focus on the geometry of the icosa. So now we'll start with the cube in the dodeca. And now I'm just going to show the outline of that size 6 cube. And I'm also showing 6 yellow cubes. These are size 1. So now I'll bring in the size 6 icosa. And now you can see the difference in size in the geometry of the icosa and the dodeca. And you can see that I'm giving it a 12 segment 48 ball polar array. You can also see that the diameter of the icosa spherical profile starts in the center of the top yellow cube and the bottom yellow cube. So I think the diameter of the dodeca would be 6√3 and the icosa diameter would be 5√3. Now the polar arrays around the dodeca vectors are 6-fold and the polar arrays around the octahedron vectors are 4-fold. So now we'll show the polar arrays around the icosa vectors and they will be 5-fold. So now you can see you can rotate copies, 10 copies, and that will be a 40 ball array. It's really pretty simple when you think about it. Okay, I think I've covered all the 5 Platonic solids now. So I think I'll show this now in the top view. And now you can see that the 10 segments of 4 colored balls are really lining up beautiful to the vertices of the icosa. Anyways, I hope there's a couple of scholars that think this quad-step phyllotaxis system of order is a lot better than chaos. So this is Paul saying thank you very much for watching my video.